Let's calculate the kinetic energy in the center of mass frame of two objects that are colliding. I'm going to use prime for the center of mass frame velocity. So we have v1 prime and we have v2 prime. And recall two things. That when we calculated v1 prime in the center of mass frame, we found that this was equal to the reduced mass divided by m1 times the relative velocities of the two objects, v1 prime minus v2 prime. Now, in the center of mass frame, this quantity is a reference frame independent, and so we can just write that as v12. It's the relative velocity is reference frame independent. So we also knew that v2 prime was equal to minus mu over m2 v12. So now let's calculate the kinetic energy in the center of mass frame. So kcm is 1/2 m1 v1 prime squared plus 1/2 m2 v2 prime squared. Now let's use our results in terms of relative velocity. So we have 1/2 m1 mu over m1 times v12 squared, because we're squaring that, plus 1/2 m2 mu. The minus sign doesn't matter anymore because we're squaring it. v2 squared. I could put that in there, it wouldn't matter. And now what we have is we have a half. One of the m1's cancels, so we have a mu squared over m1 v12 squared plus 1/2 another mu squared over m2 times v12 squared. So I pull out the common terms, mu squared, v12 squared. I have 1 over m1 plus 1 over m2. But recall that the reduced mass was precisely 1 over m1 plus 1 over m2. And so I get 1/2 mu times v12 squared is the kinetic energy in the center of mass frame. So what that means is a way of thinking, if this were just a simple reduced mass problem with a relative speed of v12 squared, I can write down the kinetic energy. But that's the kinetic energy in the center of mass frame. And therefore, the change in kinetic energy is, in a collision, is just 1/2 v12 initial final squared minus, and it's the same mu, so we'll just put a parentheses, minus v12 initial squared. And if the collision is elastic, remember our elastic collision showed that v12 initial was minus v12 final. So an elastic collision satisfies that condition, and you can see directly that delta kcm is 0 in that case. And a completely inelastic collision has the two objects moving together at the end, so v12 final is 0, so completely inelastic. Is the condition that v12 final is 0, because the objects stick together. And we have a very simple result for the change in kinetic energy for completely inelastic collision. It's only negative 1/2 mu v12 initial quantity squared.